One of the new features available starting with GREET 2016 is the Scenario Manager. This feature allows a user to create scenarios involving changes to pathways and processes, and then compare the results. In this video, I'll explain why the Scenario Manager tool was added to GREET. Then I'll review its features, and finally, I'll use some examples to show how the tool is used. So let's get started. The Scenario Manager allows users to track and analyze the influence of changes to one or more parameters in pathways that they work with. Often users will change input amounts or other process attributes to adapt the default GREET values to their specific application. In previous versions, GREET only allowed users to save one configuration of their pathway, requiring separate iterations of the GREET database for every unique application or scenario. With GREET 2016, the Scenario Manager allows a user to save and manage multiple sets of inputs or parameters for any pathway without the creation of new pathways or management of multiple GREET database files. This tool records changes to values, but doesn't alter the model structure, so users can test various fuel mixes for the same pathway or track regional variations to measure the emissions impact between locations without creating alternate versions of GREET. Scenario results features allow comparison of multiple scenarios easily and quickly. Now let's tour the Scenario Manager in GREET 2016. At the far right of the screen is a button with two angle brackets. Click this button and a tab expands to show the Scenario Manager tool. Starting at the top, we first see a field showing the file name of the loaded scenario file. GREET attempts to load or create a scenario file based on the .GREET database that you have loaded, but you can change the name if you'd like. Next to the field, there is a Save button to save your file in .csv format, and a Load button to bring in a previously saved file. Below the scenario file, you'll see which scenario is active. The active scenario is the scenario that will be modified as you make changes to GREET. If you haven't selected or have deselected an active scenario, this area will say None. Next below is the Scenarios frame, where you build your scenarios, and you'll see a few buttons here. The first is for creating scenarios, so clicking the button generates a new scenario that appears in the field directly below, and you can create as many new scenarios as you'd like using this button. The next two buttons help you direct which scenarios are modified when changes are made in the model, and I'll show how to use these in the example demonstrations. The field below the buttons is where your scenarios will be listed. Each scenario saves all parameters that are modified from the default GREET values. You can switch between scenarios by double-clicking on one to make it the active scenario, then altered parameters and inputs that you make to GREET will save to that scenario. Scenarios can be renamed or deleted by right-clicking on them. After a scenario has been modified, a small button appears next to the scenario name, and a hierarchy tree can be expanded to show parameters modified in that scenario, grouped by process, technology, transportation mode, etc. It's necessary to tell GREET which results you are interested in tracking, so to record the results of a pathway or mix, simply open that item in the WTP pane, right-click somewhere in the main frame of the WTP pane, and select Scenario Manager Record This pathway or mix, whichever it is. The same goes for recording vehicles in the WTW pane. The pathway, mix, or vehicle will then appear in the field under Recorded Pathways Mix Vehicles. Run Simulations is the button you'll click when you're ready to generate results after you've selected pathways to record. If you haven't recorded any items and you click the Run Simulations button, you'll get a pop-up message saying that no results are selected to be recorded. Or if you haven't made any changes, you'll see a message saying no need to recalculate. The recalculation will take more or less time depending on how many scenarios are created. After the scenarios recalculate, a hierarchy appears that can be expanded to see results for each scenario. A recorded pathway, mix, or vehicle can be removed, or results can be cleared by right-clicking on the item. There are two ways to view results. The first is by double-clicking on a pathway, which will open a window showing results for the scenarios within that pathway. The second way is to click one of the buttons below called Compare WTP and Compare WTW. Click one of these and a window appears where you can select a scenario or more to view, Then click Open Selected Scenarios, and a results window opens showing the scenario results for each recorded pathway. Those are the general features of the Scenario Manager, so now let's see how to use the tool. In this first example, I'm going to make scenarios using the pathway for ethanol production from corn. And I already have two scenarios constructed. The first one is a default scenario that will serve as a control without any changes, just the default corn ethanol pathway. And this is called default. In the second one, called wet mill 100%, I changed the U.S. industry average stationary process to omit the dry mill production processes and use 100% wet mill produced ethanol. I can expand this scenario to show that the process called U.S. industry average ethanol production from corn was altered, and the updated values are shown. I can also expand the default scenario to show the original values for this process. Before I create my next scenario, I want to reset the model to restore default values. So I'll click the Active Scenario equals None button to deselect all scenarios. Then I'll click the Set to Greet Defaults button to restore default values. To make sure that the reset occurred, I'll reopen my corn ethanol pathway, and the industry average default values are restored. Deselecting an active scenario with the Active Scenario equals None button ensures that changes made to greet will not be made in any of the created scenarios. If I hadn't first deselected all scenarios before resetting the values, whichever scenario was active would have been unintentionally modified. I'll create my next scenario and it automatically becomes the active scenario. Over in the pathway, I'll click to edit the stationary process called dry mill ethanol production with corn oil extraction. Natural gas makes up most of the energy input here, so I'll change the technologies so that only the small industrial boiler is used, and I'll see what kind of impact that might have. I'll rename this scenario NG Boiler. Then I'll deactivate all scenarios and restore default values. For my last scenario, I'll edit the transportation process in the pathway. And by default, rail accounts for almost 80% of the mode share for transporting ethanol, and barge accounts for about 13%. Heavy-duty truck accounts for about 10%. I'm going to change that so that barge accounts for 100% of the mode share. I'll rename the scenario barge. And if I expand the barge scenario, I can see that 3 processes have been modified in this scenario group, with 1 change in each scenario except for the default scenario. Now I want to record pathways, so I'll certainly add the corn ethanol pathway. I'll also record the ethyl acetate and ethyl lactate pathways, which use corn ethanol as an input. Then I'll go ahead and run simulations. For the purpose of the video, we'll skip ahead past the recalculating process. And if I expand the recorded pathways, you can see that I have results for each of my 4 scenarios in all the pathways. To view results, I'll first double-click on the corn ethanol pathway to see my scenario results for the pathway. On the left, there are numerical results that can be copied to Excel, and on the right is a column chart depicting the results graphically. For total energy, you can see that the barge and NG boiler scenario changes didn't make much difference compared to the default scenario, but the wet mill scenario requires more energy per unit of energy of ethanol. This is because the wet mill process, which contributes a much lower default share to the industry average than the 100% share that I implemented, uses almost twice the input energy than the dry mill process. I can also look at petroleum fuel results, and barge and wet mill use more petroleum than the default scenario. And for total CO2 results, I can see that the wet mill scenario produces more CO2 than the others, probably again due to the increased energy input, and also because the wet mill process uses more coal than the dry mill process. In this last part of the video, I'll bring in a saved scenario file and look at the effect of upstream fuel changes on vehicle emissions. First, I'll click the Load button and select my file from my saved documents, and my scenarios are loaded into Greet. I have 3 scenarios, the first being my default scenario. The second and third scenarios involved changes to a process for North American natural gas from shale and regular recovery. In increased CH4, I changed the methane leakage value in the natural gas processing process to be 100 grams higher than the default value. In no shale, I changed the averaging process for combining shale natural gas and regular natural gas so that only regular natural gas is used and shale gas has a 0% share. I'll record this North American natural gas pathway, and I'll also record some vehicles to see how their emissions may have been affected by my changes. In the WTW pane under compressed natural gas, I'll record the fuel cell vehicle, as well as the ICEV CNG vehicle. And I'll click to run simulations. Again, we'll skip forward over the recalculation. I first want to see the results for each scenario in the NG recovery pathway, and there's almost no difference in total energy across the scenarios. There's no difference in emissions between the default and increased CH4 scenarios, and only a slight difference due to the no shale scenario change. The greatest difference with the default scenario is in methane emissions, which are significantly higher for increased CH4 because of the elevated methane leakage value, and they're slightly lower in the no shale scenario. If I double-click the recorded vehicles to open their results, I can see similar trends for the scenarios related to methane results, though the effects are less pronounced because the changes from that one upstream process get diluted over the life cycle of the fuel pathway. Finally, I'll close the results windows and I'll save my scenarios file with the updated results. That concludes this overview of the Scenario Manager tool. We'll post another video soon showing some more advanced features of the tool, so stay tuned for that. Until then, explore the Scenario Manager to build familiarity with it because it can be a really useful tool for certain applications. Thanks for watching.